Yes, it's Rick.
Is it? Okay.
Yeah.
Okay. Good morning, Year 12 Physics. This is your first COVID-19 physics update. We're going to learn about types of wave today. And there's two different types of wave that you've got to know about. The first one is longitudinal. Longitudinal is when the thing that the wave's travelling through is compressed in the direction of the wave. So, I have a spring here, and when the wave is a longitudinal wave, it means that the spring is compressed like this, compressed in the direction that the wave travels. And so you might see something like, you can see the wave reflecting backwards and forwards. It zooms back and forward along the spring. So the thing we have to know for longitudinal wave is that the medium is displaced in the direction of wave travel. And I can hear you asking, what sort of wave is a longitudinal wave? Examples of longitudinal waves are things like sound waves. Sound waves are the classic one. So when I talk, the little air molecules between me and you are banging into each other, and that little banging is banging on the drum of your ear, and so your brain interprets that banging as a signal, a sound signal. And so the longitudinal waves are sound waves. The second sort of wave we have to learn about are transverse waves, which are kind of the opposite to longitudinal waves. That's when the medium, the thing that the wave's travelling through, is displaced at right angles, like perpendicular to the direction of wave travel. And so the spring goes up and down, the medium goes up and down like this when the wave's travelling through. Check out what that might look like. Try that one again. That was a bit too big. Not very well attached. So, the way the medium goes up and down as the wave travels along. And so the second one, get rid of that first one. We're going to do some pictures in a second. It will all make sense. The second one is transverse. That's when the medium, the thing that the wave's travelling through, the medium is displaced at right angles to wave travel. What do we mean? Like perpendicular. And so, what sort of wave is a transverse wave? I can hear you asking, when's that real in real life? Light. Light waves, and in fact light waves is just like a type of electromagnetic wave. So I'm going to send you a link to a video, a sing-along video where you can learn the names of all of the different types of electromagnetic wave and like in order of wavelength, because that's the sort of thing that we should know. Electromagnetic waves. We often just call them EM, electromagnetic waves. So we have two types of wave: longitudinal, where the medium moves backwards and forwards as the wave travels along, and transverse, as the medium moves up and down as the wave travels along. Some little pictures. Okay, some little pictures. What do these different types of wave even look like? the longitudinal one, when we're drawing it, what we're often drawing is areas of compression and then areas of rarefaction. It's the opposite to compression. Then areas of compression, areas of rarefaction. So where the lines are further spread apart, that's where the particles are further spread apart, and where they're closer together, the particles are closer together. So compression and rarefaction. And so what way have the different particles moved? Well, in order for the area of compression to exist here and the area of rarefaction to exist here, that means that some particles must have moved away from the area of rarefaction towards the area of compression, and over here the same, away from the area of rarefaction and towards the area of compression. And so that's like what a longitudinal wave might look like and how it's formed. With the transverse wave, that's much more like what we've been practicing drawing in class in the past. Check this out. It's when you have that beautiful sinusoidal shape, that classic wave shape, where the particles have been displaced this way, is the displacement, and the wave has travelled this way. So if we think about that the whole way along the wave, then some more displacement that way and some displacement that way, starting from an equilibrium point along there, going back to our longitudinal wave. Which way has the wave travelled here? It's travelling that way. Wave travel. And so what you can see is that on the longitudinal one, the particles are displaced parallel to wave travel, and on the transverse one, the displacement is perpendicular.